Welcome to this section where we will learn how to use Riverpod, which is a powerful package that helps us with state management and much more in Flutter. And let me just say that this is one of the core sections of the entire course that will build upon what we have learned about app architecture, and we will really start to get a good understanding of how things fit together. So this is what we will cover. We will start off with an introduction to Riverpod so that we can get a good feel for what problems it helps us solve. Then we'll install it and set it up in our project. And we will start simple by using it as a dependency injection system so that we can declare providers that we can use to access the repositories inside our widgets. And as part of this, we will learn about consumer widget as well as the concept of ref, which is an object that we can use to access all our providers. Then we will focus on how to read asynchronous data and learn how to work with stream provider and async value as an alternative to stream builder and async snapshot, and how async value helps us reduce boilerplate code when mapping different data, loading, and error states to the UI. We'll then learn about two very important modifiers known as family and auto-dispose, which are essential in a number of different scenarios. And we'll wrap up by creating a reusable widget class that builds on top of async value and helps us reduce boilerplate code. And if I had to summarize all these points in one sentence, I would say that this section is about understanding how data flows from the repositories and into our widgets, and how Riverpod helps us connect everything together while also giving us APIs for disposing things properly. So if you've never used Riverpod before, I recommend that you follow all the lessons closely, because in the coming sections we will build upon what we learned here. On the other hand, if you're already familiar with Riverpod, you can probably speed through the first few lessons, though I still recommend that you follow the lessons about async data and modifiers more closely. And by the end of this section, we'll have covered many essential Riverpod APIs and we'll understand how to use it to read data going from the repositories and all the way into our widgets, focusing on the functionality to show product listings and product page details. But of course, reading data is only half of the story, and we'll also need to figure out how to respond to user events and write data by going in the opposite direction across all these layers. And to do this, we'll need to cover some additional concepts that go beyond the basics. And we'll explore all of this in the next section by implementing user authentication, so that we can understand the entire flow for signing in and signing out of the app. And as we go through these two sections, we'll cover most of the things that you need to work effectively with the Riverpod package. But of course, we have an entire e-commerce app to build, and in addition to product listings and authentication, we'll also cover other interesting features such as shopping cart, checkout flows, orders management, reviews, as well as many others. And before we even get to those features, I think it's really important that we talk about testing, because testing has an influence on many design decisions that we make with our code. So before we move on to all the remaining features, I'll include an extensive section about automated testing so that we can really understand how to test all these layers individually and as a whole. So as you can see, we have a lot of ground to cover, and I hope that you're excited about this. And as we go through some of this material, I recommend that you keep the official Riverpod docs handy, which you can find at riverpod.dev. And you can also use my essential guide to Riverpod as a reference, as this is a long article that covers most of the Riverpod APIs in a logical manner. So let's continue on the next lesson, where I'll give you an introduction to Riverpod. Welcome to this introduction to the Riverpod package. And as you may know, Riverpod is described as a state management library for Flutter. And when it comes to Flutter, there are a ton of ways to manage state. And if you really want, you can go quite far with the state management APIs that Flutter offers out of the box. And these include stateful widget and set state, inherited widget, and useful classes such as change notifier and value notifier, along with reactive widgets such as value listenable builder and animated builder. And while I'm not going to discuss these in detail here, you should have at least a basic understanding of how they work. And if you want to explore this in more detail, I've included a good overview of all these APIs in this article, which includes many useful resources as well as some of the official videos from the Flutter team. And of course, there are also a ton of different packages that can help you with state management, including Provider, Flutterblock, RxDart, Getit, MobX, as well as many others. And I can tell you with confidence that all these packages give you some very robust APIs for doing state management. However, as far as we are concerned, we are going with Riverpod, because Riverpod was created by the author of Provider to make some improvements that would be otherwise impossible. And since I've used Riverpod for over 1 year in all my apps, I can say with confidence that it is a very powerful solution for many different reasons, and we'll explore all these reasons in detail as we make progress. But before we move forward, I think it's useful to give you a conceptual understanding of what Riverpod really is. And the way I like to think of it is like this. At the core of Riverpod, we have a dependency injection system, which is something that we can use to declare all of the application's dependencies. And in our case, this will be the data sources that we connect to, as well as the repositories that give us the data that we need to show in our widgets. And as we will see, services and controllers are dependencies as well. And one very distinctive feature of Riverpod is that all dependencies can be declared inside global providers. That's right, all providers in Riverpod are declared as global variables. And what that means is that unlike with other packages, Riverpod providers live outside the widget tree. And this is something that you may find confusing at first, but trust me when I say that this was a very good design decision, because if providers live outside the widget tree, you can access them easily in multiple places without having to create complex widget trees, which was one of the big drawbacks of the provider package. And as we will see, we can still have providers that depend on other providers, and Riverpod gives us a nice and unified API for doing so. Alright, so what we said so far is that Riverpod can work as a dependency injection system that makes dependencies available to our widgets by using some global providers. But beyond that, Riverpod is also a state management system that allows us to deal with various sources of data that can change over time. And in order to help us with all those different sources of data, we get specialized providers such as state notifier provider, stream provider, future provider, along with some modifiers that we can use to tweak the way they work. And on top of that, providers can depend on other providers, and Riverpod is designed to do the right thing and rebuild providers as needed on our behalf. So we'll have plenty of time to explore Riverpod as a state management solution, but there is more than that. In fact, I want to point out that the official homepage describes Riverpod as a reactive caching and data binding framework. So really, Riverpod goes beyond simple dependency injection and state management, and as we will see, we can use it to combine different types of providers in many interesting ways and configure it to do data caching and disposing things as needed. In fact, the master plan for Riverpod is quite ambitious and goes beyond what other state management packages do. And in the future, Riverpod will even be able to take care of data mutations for us by introducing some advanced features that will rely on static metaprogramming, which is a feature that is in the roadmap for the Dart language. But as we wait for these advanced features to be implemented, we can already make the most of what Riverpod offers today. And as we'll see, there is already a lot of good stuff to keep us busy. And the main takeaway of this lesson is that just like widgets are the primary building blocks for building apps with Flutter, providers are the primary building blocks for managing state in Riverpod. And in fact, the main purpose of a provider is to encapsulate state and to make it possible for widgets to listen to that state and rebuild themselves when it changes. And if we explore the official documentation, we can learn that there are various providers that were created to deal with different use cases. And as we make progress, we'll focus primarily on these 4 since they are the most useful ones. So let's continue on the next lesson where we'll install Riverpod and start using it. In this lesson, we're going to install the Riverpod package and set things up so that we can use it in our app. And if we go on the official page for Riverpod, we can find that there are 3 different packages called Flutter Riverpod, Hooks Riverpod, and Riverpod. So which one should we use? Well, as we can see, Riverpod is a pure Dart package that does not depend on Flutter itself. And this could be useful if you wanted to write server-side Dart code or perhaps a command line tool built in Dart. But as far as we are concerned, we are building a Flutter app, so we had to choose either Flutter Riverpod or Hooks Riverpod. And the difference between these two is that Flutter Riverpod is the main package that is used in most projects, and instead, Hooks Riverpod is a separate package that gives us a way to use both Flutter Hooks and Riverpod together. And when it comes to managing the widget lifecycle methods, Flutter Hooks are a great solution to reduce boilerplate code, and they can replace stateful widgets altogether. However, we are not going to focus on Flutter Hooks at this stage, because for now it's much more important that we learn how to use Riverpod as a state management solution. And this means that the package that we want to install right now is Flutter Riverpod. And as I record this video, Riverpod 2.1 has been officially released. And if we take a look at the changelog, we can see that both Riverpod 2.1 and 2.0 bring a number of breaking changes compared to the previous version. we choose Riverpod 2.0.0 Dep 9. So going forward, we are going to use Riverpod 2.1, which contains a number of important bug fixes. And by the way, I should mention that alongside the Riverpod 2.0 release, a new Riverpod generator package has also been introduced. And the purpose of this package is to make it easier to create various kinds of providers with a new modern syntax that builds on top of the existing Riverpod APIs. But just to be clear, in this course we will focus on the main Riverpod package, so that we can really understand how to use it. And I will cover the new Riverpod generator package as a separate section at the end of the course, and share some new articles and resources that you can use to learn how to use it. Okay, so let's get back to VS Code and add Riverpod to our project. And at this stage, I recommend that you grab the updated starter project from the resources below, since this contains some updated packages and small changes that we will use going forward. So make sure that you grab the updated starter project and open it in VS Code. And then we can head over to the pubspec.yaml file. And as we said, we are going to use version 2.1.1, so we can copy this from here, and then get back to the pubspec.yaml file and paste it in here. And just to be clear, what we have said is that we want to use the Flutter Riverpod package. And I recommend that you use exactly this version to make sure that your code is in line with the course project. And now that we have added this, we can get the latest packages. And then we can start using Riverpod. And the first thing that we need to do every time we add Riverpod to a new project is to go to the main.dart file. And as you can see, this file contains some updates to the error handling code, since the recommended way of handling errors has changed with the release of Flutter 3.3. And if you want to learn more about this, you can follow this link. But for now, the most important thing is that we focus on this line where we run our app. And what we want to do is to wrap this widget with a provider scope, which is a widget that we need to import from Flutter Riverpod, like this. And then we can save our file and run our app on any of the available devices. And just to be clear, it is absolutely critical that we add a provider scope at the very root of the widget tree, because this is a widget that maintains the state of all the providers that we will create inside our app. Okay, so at this stage, you should have the app running over here, and we can continue on the next lesson. In this lesson, we're going to learn how to use Riverpod as a dependency injection system and start getting familiar with the Riverpod APIs. And if you remember, the last thing that we did in the previous section was to create this fake products repository class as a singleton that we were then accessing in all these different widgets. And what we said back then is that using the singleton pattern like this is not a good idea. And the reason it is not a good idea is that using singletons in our widgets makes them hard to test. And we'll discuss testing much more in depth in one of the upcoming sections. But for now, all I want to say is that if we have a widget that depends on a repository such as this one, then it's not possible to replace this repository with a different one that we use for test purposes. And that's because when we use singletons like this, what we are doing is hard coding dependencies inside our code. So let's see how we can address this by using Riverpod as a dependency injection system. So what we are going to do next is to declare a provider that will give us access to the fake products repository. And then inside our widget, we will find a way to use that provider and get the repository. So let me show you how this all works in practice. And the first step is to open the fake products repository. And what we want to do is to declare a provider. And if you haven't done this already, I highly recommend that you install the Flutter Riverpod Snippets extension by Robert Brunhage, as we will use it extensively going forward. Okay, so let's get back to our fake products repository, and then we can scroll over here to the bottom, and then we can start typing provider. And then we can select the first option that appears on this list. And as you can see, this generates some boilerplate code for us. And what we had to do is to give a name to this provider, such as products repository provider. And we must also give it a type, which in this case is fake products repository. And we need to remember to import Flutter Riverpod. And as we can see, this provider takes one argument, which is an anonymous function that gives us a ref object. And I'll explain what this ref object is very soon. But for now, we don't need it. And all we had to do is to return an instance of our fake product repository. And right now, the only way we can do this is by calling .instance, like this, because we have declared this as a singleton. And as we will see in the coming lessons, we will always use this provider to retrieve this repository. So strictly speaking, we no longer need this to be a singleton. But for now, let's stay on track and leave it like this, and we'll remove this singleton declaration later on. And by the way, this syntax that we have just used is something that we will use over and over. And when creating providers with Riverpod, there are 3 things to keep in mind. The first one is that providers are declared as global variables, like we have done here. And this means that anywhere in our project, we can access this provider as long as we import the file where it is declared. The second one is that providers always need a type annotation, and this tells us exactly what type of object they return. And the third one is that providers have a body, which is a function argument that we can use to return an instance of the type that we have specified. And in this case, we are just returning this object as a single line. But as we will see, this function can be quite complex, and we'll be able to use this ref object to access other providers as dependencies. And just for reference, this syntax is quite different to what you may be used to if you use the provider package, where all providers are widgets themselves that are inserted directly in the widget tree. But as it turns out, declaring providers as global variables is a much better design decision, and we'll see the advantages of this going forward. However, it does mean that we need to choose where in our code we should declare these providers. And while there isn't any recommended guidance on this, what I found works well in practice is to declare providers in the same file where we declare their type, like we have done over here. And just to be crystal clear, here we are declaring a provider of type fake products repository. But in fact, we can create providers of any kind of type in Dart, including primitive types such as string or integers, booleans, and so on. And for now, this is all we need to know. So let's remove these 2 providers, and we can continue on the next lesson where we will see how to use this provider. In this lesson, we are going to learn how to use this provider in our widgets. And as part of this, we will learn about 2 important Riverpod widgets known as consumer widget and consumer. And as we know, there are currently 4 places in our project where we access our fake products repository instance. For example, we can open the products grid widget, and as we can see, in the build method, we access the list of products with this syntax. So let's see how we can change this to use the provider that we have declared. And a very important thing to understand is that when we use Riverpod, we should always access our providers by using a so-called ref object. And the easiest way to get a ref object is to convert our widget parent class to consumer widget. And in order for this to work, we need to import Flutter Riverpod. And when we do this, we get an error on the build method because the build method of consumer widget gives us 2 arguments. The first one is a build context, and the second one is a widget ref argument called ref. And just like the build context allows us to access other widgets up in the widget tree, the widget ref object allows us to access all the providers that we have declared. In fact, now that we have this, we can remove this to do, and then we can type final products repository equal to ref dot. And as we can see, here we get a list of methods, and I'll explain what these methods do later on. But for now, the one that we want is called watch. And this takes an argument, which is the name of the provider that we have declared in this file. So we can copy the name of this provider, and then we can paste it in here, like this. And now that we have this, we no longer need to use this singleton, and instead we can just type products repository.getProductsList. And just to be clear, if we hover over this provider variable, we discover that its type is provider of fake products repository, as expected. And if we hover over this variable, we find that the type is fake products repository, because this is what the provider returns. And now that we know this, we can update all the files where we were using a singleton to use this new syntax. So let's copy this line from here, and then we can open the shopping cart item widget. And here we can replace this to do with this line. And of course, this doesn't work right away because we haven't converted this widget to a consumer widget yet. So let's fix this by changing the widget base class to consumer widget and import Flutter Riverpod. And here we should also add a widget ref argument. And now that this code compiles, we can use the products repository directly here instead of the singleton variable. And then we can repeat the same process in the order item list tile. So let's convert this widget to a consumer widget and import Riverpod. Then we can add a widget ref argument to the build method. And just like we did before, we can copy this line and paste it in here. And then we can use the products repository instead of the singleton. And finally, there is one last widget that we need to update, and that is the product screen widget. So let's also convert this to be a consumer widget and import Flutter Riverpod. And we can also add the widget ref argument to the build method. And then we can copy this line from the previous file and paste it in here. And finally, replace the singleton with this variable, like this. And now that we made all these changes, we can make sure that we save all the files that we have changed. And finally, we can get back to our fake products repository. And I should point out that we no longer need this to be a singleton, because we are only ever going to access this repository using this provider. As a result, we can remove both the singleton declaration and the private constructor as well. And then inside the provider, we can just return a new instance of fake products repository, like this. Then we can save and hot restart. And at this stage, we should be able to see that everything still works in our application. Okay, so up to this point, we have learned how to create a provider. And if we get back to our product screen, we can see that in order to access this provider, we need to subclass from consumer widget. And as a result, in the build method, we get an extra ref argument that we can use to watch our provider. And one important thing that I should point out is that when we call ref.watch, then our widget will rebuild if the value of the underlying provider is updated. And in this specific case, we have nothing to worry about because this provider gives us a repository that is only created once and never changes after that. But as we will see shortly, there are some cases where we call ref.watch to read some data that changes over time. And in this scenario, we want to only rebuild the widgets that depend on our provider. For example, over here, we are getting this product from the repository, and depending on whether it's null or not, then we return this widget or this widget. But the parent scaffold and home app bar themselves do not depend on this variable. And for this reason, we can wrap this code with a consumer widget. And as we can see, this takes a builder argument, which is a function that gives us a build context, a widget ref, and an optional child widget. So let's use this builder and specify these three arguments, and then we can open some square brackets. And then we can pull this entire block of code inside it, and we can return this as a widget, like this. And then what we are going to do next is to take these two lines that we had at the top of the build method, and we can also move them inside the builder, like this. And as a result of making these changes, then only this builder will be called again if the value returned by this provider changes. And that's because here we are using the ref that comes from the builder itself, and not the one in the build method. And this also means that we can convert the parent widget back to a stateless widget and remove this ref argument from the build method. So in essence, consumer widget and consumer give us two ways of doing the same thing. And the difference is that with consumer widget, everything in the build method will rebuild if the provider value is updated. Whereas with consumer, we get more fine-grained control about what widget we rebuild at the expense of more boilerplate code. And in this specific case, there is no practical difference because we only create the products repository once and it never changes after that. But in the coming lessons, we will modify this code so that we can read some asynchronous data that can change over time. And in that scenario, it will be worthwhile to use consumer for performance reasons. And by the way, since we have just refactored a few files, you can find an updated code snapshot in the resources for this lesson. Okay, so let's continue in the next lesson where we are going to start digging deeper. Now that we have seen how to use consumer widget and consumer in our widgets, we are ready to learn about stream provider and async data, which are two very useful classes for dealing with asynchronous data with Riverpod. And if we go back to our fake products repository, we can remember that in the last section we have added some future and stream-based APIs to our repository, because these are the kind of APIs that we would like to use if we were connecting to a real backend or a REST API. And we said that in Flutter, we can use Future Builder and Stream Builder to map asynchronous data to our UI. But the Future Builder and Stream Builder widgets force you to work with Snapshot, which requires a lot of conditional code to get the job done. And in this article, I've already mentioned that Riverpod offers a much better alternative. So let's go back to our project and see how we can work with asynchronous data using Riverpod. And one important thing that we need to understand is that whenever we want to read data from a future or a stream, we should declare either a future provider or a stream provider. And we should declare one provider for each of the methods that we want to use. For example, if we want to read data from this method that gives us a stream of products, then we can go to the bottom over here, and then we can start typing stream, and we can select stream provider from this list of options. And then we can call this products list stream provider and use list of type product as the type annotation, because this is the type of stream that is returned by this method. Then we can remove this async star keyword because we are not using a stream generator. And then inside the provider body, we can type final products repository equals ref.watch. And we can pass products repository provider as an argument. And finally, we can return products repository.watch products list. And as you can see, we have just done something interesting, because in this line, we have retrieved the products repository by watching the products repository provider that we have declared over here. And then we have used it to return the stream that is returned by this method. And this syntax should already look familiar, because what we are doing is to use this ref object to watch a certain provider. And this is exactly the same syntax that we have used in our widget. And this means that whether we are inside a widget or inside a provider, we can always access other providers as long as we have a ref object. And now that we have this, we can get back to our products grid widget. And here, rather than watching the products repository provider directly, we should watch the products list stream provider that we had just created. And if we hover over this variable, we can find out that its type is now a sync value of list of product. So let's rename this to product list value, and then we need to figure out how to use this async value. So let's delete this line, and instead we can type return product list value dot when. And then we can select this method from the list of options. And as you can see, this method gives us three arguments called data, error, and loading. And if we hover over these arguments, we discover that they are actually functions that we need to use to return a widget. So let's implement them. And inside this data callback, we get an argument, which is our list of products. And since this is a callback, we can use the arrow operator. And the return code should be this whole chunk of code that we used to return before. So let's cut all these lines from here and return them in here. And then we need to return widgets for the error and loading states. So as far as the error goes, we get a callback that gives us an error and a stack trace. And we can use this to return an error message widget, which is one of the common widgets that I've included in the starter project. And this widget takes an argument that we can use to represent the error message. So we can type e.toString, for example. And it's also a good idea to wrap this with a center widget, like this. And finally, we have this loading case, which is a callback with no arguments, and we can just use this to return a circular progress indicator. And we should also wrap this inside the center widget, like this. Okay, so let me just explain this code that we just added. And the most important thing to understand is that when we call ref.watch on a stream provider, then our widget will rebuild every time the stream emits a new value. And this is very important, so let me say it again. Whenever we watch a stream provider, our widget will rebuild every time the stream emits a new value. And because streams emit asynchronous data, then we must handle three different cases called data, error, and loading. And Riverpod gives us a convenient async value type that makes it easy to map these three cases to different widgets. And it does so in a compiled safe way, making it impossible to forget the loading and error states. And if you have worked with Stream Builder or Future Builder before, you should appreciate how much nicer it is to work with this syntax. However, let me stress out that a sync value is just a value and not some kind of listenable object. And the thing that really takes care of rebuilding our widget is this call to ref.watch with the stream provider as an argument. And by the way, what we just said about stream provider works exactly in the same way if we use a future provider instead. And as a proof of this, we could get back to our repository. And if we want, over here, we can copy this entire provider and paste it in here. And then we can rename this provider to product list future provider and replace this with future provider. And because this is a feature provider, then we can no longer use this method to return a value, because this returns a string, and instead we should return products repository.fetch products list, which returns a feature instead, like this. And now that we have this feature provider, we can save the file and get back to our products grid. And if we want, here we can swap this provider for products list feature provider. And everything else will work exactly in the same way, because we still get an async value when we watch this. And this is quite nice, because all we have to do is to call async value.when to handle the data, error, and loading cases. And once again, if this is the first time that you use Riverpod, this syntax may look a bit unfamiliar, but trust me when I say that you get used to it pretty quickly. Okay, so let's continue on the next lesson, where we will test all this new code. Now that we have learned how to work with asynchronous data in our widgets, it's a good time to test our app and check that everything still works. So if we hot restart at this stage, we can see that all the products are still visible, and we don't really have any way of testing the loading and error states. And the reason for that is that if we go back to our repository, we can see that the feature that is returned by this method returns a value immediately. And this means that as soon as we watch the corresponding feature provider in our widget, then the data callback is executed, and we return the list of products. So how can we test the loading and error states? Well, since this is a fake repository, we have full control over what is returned by these methods. So if we wanted, here we could modify this method and add an artificial delay for testing purposes. And in Dart, we can do this by marking this method as async, and then inside the body, we can add a delay of 2 seconds using the future.delayed API. And now that we have this, we can hot restart. And as you can see, we get a circular progress indicator for 2 seconds before the list of products appears. And if you're not entirely sure why this happens, keep in mind that when we call ref.watch, our widget will rebuild every time there is a new value. But of course, the build method needs to return a widget as soon as it is called. And if we call ref.watch on a feature provider and the feature hasn't completed yet, then we'll get an async value with a state of loading. And as we know, in this case, we return a circular progress indicator. And then as soon as the feature completes, then our widget rebuilds and we get a data value that we can use to show our UI. And if we wanted, we could test the error state as well by going to the repository. And here, rather than returning a feature, we could throw an exception with a message of connection failed, for example. And if we hot restart now, then we get the loading indicator for 2 seconds, and then we get an unhandled exception breakpoint. And if we resume the execution, we can see that this is now shown in the UI. And this proves that we have implemented all these 3 cases correctly in our widget. And now that we understand how this works, we can remove this exception. And by the way, if we wanted to add a delay even inside this method that returns a string, we could try to copy this line from here and then paste it in here. But this is not valid code because this is not an async method. And the way to fix this is to convert this to a stream generator by using the async star syntax. And then inside the method, rather than returning stream.value, we could yield our product variable instead, like this. And then we could save and get back to our widget. And here we can try to watch the product list stream provider instead. And if we hot reload again, we can see that we get a loading indicator followed by the grid of products. And this confirms that our asynchronous code works for both providers. And since we'll be doing some more testing with this stream, we can keep this delay in here to make sure that we always see a circular progress indicator when we subscribe to this stream. And as we can see, the fact that we decided to implement this fake products repository rather than connecting to a real data source has some advantages. Because when it comes to testing, it is really easy to modify these methods and add some delays or throw exceptions. And all of this will come handy later on. Okay, so let's continue on the next lesson. In this lesson, we're going to talk about family, which is a very useful modifier that lets you pass an argument at runtime when using a provider. So let me start off by showing you an example where we are going to need this modifier. So as a first step, we can open the product screen file where we can find this widget. And as you can see, inside the build method, we have this consumer where we get our repository and use it to get a specific product by ID. And from a UI point of view, this product ID is passed as an argument when we create the product screen widget so that we can show the correct product information when we select an item from this list. And from a data point of view, we can click to reveal the definition of this method. And we can see that this ID is passed as an argument so that we can get the corresponding product from this list. However, our intention is not to use this synchronous method called getProduct, but instead we want to use this watchProduct method that returns a stream. And as we have seen in the previous lessons, whenever we want to use a stream, we should create a stream provider that we can then watch inside our widget. So let's try to create a stream provider for this method. And if we scroll to the bottom, over here we can add a final product provider equal to stream provider, and we can pass a nullable product as the type. And then inside the body of the provider, we can get our products repository like we had done before by calling ref.watch with products repository provider. And then we can return products repository.watch product. And as we can see, we now have a problem because this method takes an ID, but inside the provider we don't have access to it. And in this kind of scenario, we can add the family modifier right after the stream provider. And this will let us add an argument to our provider. And the way this works is that we need to specify the type of our argument. So in this case, it will be a string. And then we need to add a second argument after the ref object. And we can simply call this ID. And now we can pass this ID to this method, like this. And now that we have done this, we can get back to the product screen so that we can use our new provider. And inside this consumer, we can now remove these two lines. And instead, we can type final product value equal to ref.watch with product provider as an argument. And as we can see, we get an error reminding us that we are using a stream provider family. And this means that we need to open parentheses inside here and pass the product ID as an argument. And if we hover over this variable, we can see that we now get an async value with a nullable product, which is what we want. So the next step is to return product value dot when, and then we need to implement these three callbacks like we had done before. So let's do that. And in this case, the data callback gives us a product that we can use to return all this code. So we can cut all of this from here and we can paste it in here. And then we need to specify the error and loading states. And for this, we can reuse the same code that we had in the products grid. So let's go over here and copy these two lines. And then we can get back here and paste them like this. And we also need to import our error message widget like this. And now that we have added this, we can hot restart and test our code. So as we can see, here we get the products grid. And if we select any of these products, then the product screen will open and we get a circular progress indicator for 2 seconds before the product appears on screen. And the reason for that is that in the fake products repository, we have added this delay in the watch products list method, which in turn is called by the watch product method. And this means that whenever we watch the stream provider that returns this method, then we also get a delay. In summary, whenever you need to pass an argument to a provider, and this argument is a value that can change at runtime, such as this product ID, then you can add the family modifier, like we have done in this example. And then in your widget, you need to watch this provider by passing the argument that you wanted. And in this case, what we needed to pass was just a string. However, when you work with family, you can pass any argument that you want, including other built-in types, such as int, double, or bool, as well as custom classes that you create, as long as you implement the hash code and equality operators. And the reason that you need to do this is that Riverpod will use them to determine if two values are the same or they are different. In fact, creating a provider with a family, like we have done in this case, is essentially the same as declaring a map of providers, where the keys are strings and the values are providers. And all Riverpod does is to give you a convenient syntax for creating a family of providers that can be indexed by passing an extra argument. And as you work in your own apps, you may wonder when you should use the family modifier. And the most common use cases I can think of are the one that we have just covered, where we pass a runtime argument, such as a product ID, to a widget when we navigate to a detail page and we want to fetch some data using that ID. And another similar use case is included in the Riverpod documentation, which presents this example where we have a future provider that takes an ID argument, and this is used to create a URL to a network resource that we can fetch using the DIO client. And by the way, if you find yourself creating complex types or passing lists and maps to a family argument, then chances are that you may be doing it wrong, and there may be a simpler way of designing your providers. In any case, we'll see more examples of family as we make progress, so you'll get a better feeling for when to use it. Okay, so let's continue on the next lesson. In this lesson, we are going to look at another important Riverpod modifier known as auto-dispose. And if we open the auto-dispose page in the Riverpod documentation, we can read that a common use case is to destroy the state of a provider when it is no longer used. And it also tells us that this is advisable when using Firebase to close the connection and avoid unnecessary cost, or to reset the state when the user leaves a screen and re-enters it. So let's get back to our project and see if we should use auto-dispose in our providers. And the question we need to ask ourselves is which of these providers should be disposed when we no longer use them. And a good way of finding this out is by adding some breakpoints or some print statements inside these providers to figure out when they are created. For example, inside the products list string provider, we could add a debug print statement with a message that says created products list string provider. And in order to use debug print, we need to import foundation.dart. And then inside our product provider, we can add another debug print that says created product provider with ID, and we can pass this ID using string interpolation. And then we can open the debug console and restart our application. And as we can see, as soon as the application is loaded, we get this log on the console. Because this page needs to read the data from this provider in order to show the list of products. And then we can try to select the first product. And as soon as we do that, we can see this other console log with the ID of the first product. And the next question that we need to ask ourselves is what happens when we leave this page by pressing the back button? And as we can see, we get back to the products list. But is this provider still active or has it been disposed? Well, one easy way to find out is to open the same page again. And as we can see, this time we don't get a loading spinner and we don't get a console log either. And this should give us a hint that in fact this provider is still active and listening to the stream. However, if we go back once again and we choose a different product, then this time we get a loading spinner and a new console log. And if we continue doing this and keep selecting different products, then we can see that our console log fills up with new lines. And this means that even though we are only showing a single page at a time, we have multiple active providers that are listening to different streams. And this is a problem, because if we are connected to a database such as Cloud Firestore, it will cost us money to have multiple active streams that are not in use. And the solution to this is that we should dispose our providers as soon as we no longer need them. And Riverpod gives us a very easy way to do that, and that is to use the auto-dispose modifier. And we should use it especially when working with stream provider and future provider. So let's add it to all these providers, like this. And as you can see, auto-dispose can be combined together with the family modifier if you need to. And now that we have this, we can hot restart our app once again. And now when we open the product page, we can see that the corresponding provider is created. And what is really interesting is what happens when we leave the page and come back to it. And as we can see, we now get a little badge telling us that the provider was created again. And we are also going to see the loading spinner every time we get back to this page. And this means that Riverpod is smart enough to dispose this provider and close the connection to the stream when we navigate back and the product screen widget is unmounted. And as a proof of this, we could also try to print a console log when the provider is disposed. And the way to do that is to type ref dot, and if we scroll down this list of options, we see a number of provider lifecycle methods that we can use, such as onAddListener, onCancel, onDispose, and many others. So let's implement the onDispose callback, and inside it we can use the arrow operator, and inside it we can add a debug print that says disposed product provider. And then we can hot restart one more time. And now we can verify that every time we push a product page, then the corresponding provider is created. And when we go back, the corresponding provider is disposed. And once again, this all happens because we added the auto-dispose modifier. And before we continue, I want to mention that Riverpod 2.0 is introducing some advanced data caching options that we can use to optimize our providers. In fact, one thing that I want to point out is that while auto-dispose will take care of disposing the state of our provider and closing the stream connection automatically, this may not always be what we want. Because if this stream connection is closed when we navigate back, and then we open the product page once again, then we need to load the data from the stream again. And if you are connected to a remote database and we pay for data reads, then this is not ideal. So it would be good if we could implement some form of data caching, or at least tell Riverpod to not dispose the provider's state immediately and instead to do it after a certain delay. And in order to help us with that, the new Riverpod 2.0 API has introduced a new method called keepAlive that we can use to hold on to the state of the provider even when it's no longer needed. And we can use this to enable data caching using a timeout. So let me show you how this works. And the main idea here is that inside a provider that has the autodispose modifier, we can call ref.keepAlive, and this will preserve the state of our provider. And to show you that this works, I can hot restart the app. And as soon as I go to the product page, then this console log will appear. And the interesting thing is that as soon as we leave the page, then we don't get another console log telling us that the provider has been disposed. And this proves that the provider is still holding on to the state. And in fact, if we open this page again, then we don't get a new fetch request. And just to be clear, using keepAlive by itself is not very useful. And what we may want to do instead is to add a timeout so that we can dispose the provider after a certain delay. And this is a common data caching approach that is used by many apps. And the way we do this is to assign the result of this expression to a final link variable. And as we can see, this is a variable of type keepAliveLink. And once we have this, what we can do is to create a timer object with a duration of 10 seconds, for example. And then we need to specify a callback. And inside the callback of this timer, we can call link.close, like this. And this will be used to dispose our provider after the given delay. So if we want to test this out, we can hot restart the app once again. And then we can open the product page, which triggers the console log. And then we can leave the page. And if we wait for 10 seconds, we can see that the provider has been disposed. So this is just a little preview of the data caching capabilities of Riverpod, which are especially useful when we have a list of items that we want to cache for a certain period so that we don't make too many calls to fetch the data from the network. And we will revisit these caching APIs in section 12, where we will implement the product search feature. But for the time being, we don't really need to worry about these advanced data caching options, and we can stick to the default behavior of autodispose and remove these arguments. And we can also remove all these print statements, like this. And then we can do a summary of what we have learned. So the bottom line of this lesson is that whenever you work with stream provider, it is probably a good idea to use autodispose by default, because this will ensure that we close the connection to the stream when we no longer need it. And in general, the same applies to future provider as well. And you may be wondering how this all works under the hood. And the answer is that whenever we watch a provider inside a widget, Riverpod will add that widget as a listener to that provider, so that it can rebuild it if the value changes. On the other hand, when the widget is unmounted, for example, when we navigate back, then Riverpod will remove it as a listener. And when the last listener has been removed, then the provider itself is disposed if we have used the autodispose modifier. In fact, using autodispose gives us the same default behavior that we get when we use Stream Builder and Future Builder, because these are widgets that create a stream subscription under the hood and cancel that subscription when all the listeners are removed. However, when we use Riverpod, we have various options to configure the way providers are disposed. And if you remember, when I first introduced the Riverpod package, I told you that it is a reactive caching and data binding framework. And in fact, we had just started digging deeper and discovered that providers have their own lifecycle methods, just like widgets do. And if we want, we can use these methods to fine-tune the behavior of our providers. But in the majority of cases, we don't need fine-grained control, and we just need to remember to use autodispose when appropriate. In fact, when is it a good idea to use autodispose? Well, if you have a stream provider, chances are that you always want to use autodispose, because this will ensure that your stream connection is closed when you no longer need it. And a good example of this is when we have a detail page that we can use to view different products, like in this example. So once again, I recommend that you use autodispose by default, both with stream provider and future provider. But just keep in mind that data caching is a complex topic, and in certain cases, you may want to cache the data on the client for a certain amount of time before reading it again from the server. But for now, I just wanted to show you what APIs are available in Riverpod to deal with this. Okay, so let's continue on the next lesson. In this lesson, we're going to introduce a new reusable widget that will help us whenever we need to work with a sync value. And as we have seen in the products grid widget, whenever we have an async value and we need to return a widget inside a build method, then we can use the when method and specify the data, error, and loading callbacks. And as we will see, there will be many pages where we need to work with async value. And while the data type that we need to use is likely to change every time, we probably want to show the same UI for the loading and error states. In fact, these two lines are exactly the same here as they are on the product screen widget over here. And we don't really want to copy paste them every time we create a new widget that uses async value, because this is likely to lead to problems later on. For example, in the future, we may decide to use a different loading indicator or change the appearance of the error widget. And if we have copy-pasted this code across different widgets, then it becomes really difficult to update it everywhere. And in this kind of scenario, we should create a reusable widget that takes an async value as an input and handles the loading and error states for us. And by the way, I have written this standalone article that explains how this all works in practice. So let's go ahead and implement this in our project. And what we want to do is to find our common widgets folder, and then inside here we can add a new file and call it async value widget.dart. And inside here we can add a new stateless widget, and we can call it async value t and make it generic on type t, like this. And of course we need to import material.dart. And we only need the class name to use this generic argument, but not the constructor itself. And then we can add a final async value of type t property called value. And in order to use this, we need to import Flutter Riverpod. And then we can add a second property. And this will be a function that takes an argument of type t and returns a widget. And we can call it data. And then we can add these properties as a required argument to our constructor, like this. And then we need to implement the build method. So over here, rather than returning this container, we can return value.when, and then we need to pass the data, error, and loading arguments. So for the data argument, we can pass data because this is a function argument that matches the data that we have given as a property. And then we need to add the error and loading states. And we can borrow these from the product screen by copying these two lines. And then we can get back here, and then we can paste them in here. And of course, in order to use the error message widget, we need to import it. And then we can save. So this completes the implementation of our async value widget. And just to be clear, what we have just done is to create a reusable widget class that takes an async value as an argument and gives us a default implementation for the error and loading states. And because async value is generic on type t, then our widget as well as this function argument are also generic on type t, so that we can use the data callback like this. So let's see how to use this in practice. And as an example, we can go back to the products grid widget. And then if we scroll up over here, rather than using this syntax, we can delete this. And instead, we can type async value widget, passing a list of type product as an argument. And in order to use this, we need to import async value widget as well as the product type, like this. And then we need to give it a value argument, and this will be our product list value, like this. And as a result, we can scroll down and remove these error and loading arguments because async value widget takes care of them for us. And then we can move over to the product screen widget. And over here, we can do the same thing and delete this code. And instead, we can return an async value widget that we can import. And this time the type is going to be a nullable product, like this. And of course we need to pass in a value, which is our product value. And we can remove the error and loading states as well. And if we hot reload now, we should see that everything still works as expected. So this is good progress, but we are not done yet because there are two more widgets that are still not using the stream provider that we have created. And if we do a project-wide search for products repository provider, we can find out that we had to update this shopping cart item widget. So let's do this. So over here we can delete these two lines, and instead we can type final product value equal to ref.watch. And inside it, we want to watch for the product provider, passing item.productID as an argument. So this gives us an async value that we want to use to return a widget. And all we want to do in this case is just to wrap this padding widget with a new widget, which will be an async value widget with a nullable product. And we can import async value widget. And then for the value, we can just pass product value, like this. And the second argument is not a child, but instead is a data callback that gives us a product, and we can use this to return a widget. And as we can see, over here we get an error because this product is nullable, but the shopping cart items content widget wants a non-nullable product. However, in this case, it is safe to use the assertion operator on the assumption that this widget will always take an item with a valid product ID. So once again, this is just an assumption that I can guarantee to be true in this specific case. And now that we have updated this widget, we can test our changes by selecting the shopping cart icon. And as you can see, as soon as we do this, we get 3 loading indicators, because this page shows 3 items inside the list, and each one of them now uses a sync value widget, which will show a loading indicator until we have some data. And I will agree that having multiple loading indicators inside the list view is not great UI. So if you wanted to make this better, you could use the shimmer package, which is great for this kind of scenario. So in this case, rather than using a sync value widget, you could just use product value.when and provide some custom UI for the loading state using the shimmer package. So feel free to implement this as an exercise if you want. But as far as I'm concerned, I want to stay on track without spending too much time building UIs. And finally, we want to open the order item list tile, where we still read data from the products repository provider like this. And instead, we want to use our stream provider instead. So once again, we can delete these 2 lines, and instead we can type final product value equal to ref.watch with product provider passing item.productID as an argument. And once again, what we want to do here is to wrap this with an async value widget that takes a nullable product argument, and we can add all the required imports as usual, and then we can add a value argument, which will be our product value, and replace this child argument with a data callback that gives us a product. And in this case, we are also going to use the assertion operator over here, and then we can save and hot reload, and we can test this code by opening the orders page. And as soon as we do this, we also get 3 loading indicators until the data is loaded. And once again, this is something that you could improve by using the shimmer package. And this completes all the changes that I wanted to make. In summary, the main takeaway of this lesson is that by implementing a reusable async value widget, we no longer had to worry about the loading and error states when working with async value. And we will use this class extensively to improve code reuse across the project. But of course, there are some cases where you may want to have some custom loading and error UI, and in those cases, you can just use the regular async value.when method. Okay, so let's continue on the next lesson. We have now reached the end of this first section about Riverpod, and we have covered a lot of ground already, so let me give you a quick summary of the most important concepts that we have learned. And the first thing that we did was to use providers as a form of dependency injection. Specifically, we made some changes so that we no longer need to access our fake products repository as a singleton, but instead we have used a provider that returns our repository, and we have converted some of our widgets to consumer widget so that they can get a ref object inside the build method that we can use to watch our repository. And as we will see in detail later on, by doing things this way, our code becomes more testable. And because the fake products repository is a dependency that does not change, then we can use a regular provider to make it available. But sometimes we want to read data from a future or a stream-based API, and this data can change over time. And in this case, we should create a future provider or a stream provider, like in this example. And inside the widget, we can watch that provider using exactly the same syntax. And when we do this, we need to keep in mind that our widget will rebuild every time the data changes. And we can use the resulting async value to map the data, error, and loading states to the UI. And we have also seen that we can create a helper async value widget that takes care of the error and loading states for us. And we have also learned about the family modifier. And we said that it's very useful whenever you have an ID or an argument that you need to pass to a provider in order to obtain the data that you need. And we have also learned what is the role of the auto-dispose modifier in closing any open stream connections by disposing the state of our provider when it is no longer used. So overall, the focus of this section was on how to access dependencies in our widgets by watching the corresponding providers, as well as how to read asynchronous data and dealing with loading and error states. And as we have seen, Riverpod offers a unified API to do this by giving us a ref object that we can use to watch our providers. But in addition to accessing dependencies and reading data, we also need to learn how to manage application state, as well as use our repositories to write data. And this will be the main focus of the next section, where we will dive deeper into state management with Riverpod. But I think it would be already quite valuable for you to try and use Riverpod in your own apps and get some practice working with providers, consumers, and asynchronous data. And before we move on, I'd like to give you an exercise, and that is to grab the starter project that I shared at the beginning of this section and see if you can repeat all the steps that we have covered and understand how everything works. And you can try to do this independently without watching the videos. And you can find some more detailed instructions about this in the notes below this video. Okay, so let's continue on the next section.